having to do with how the greenhouse works.
The greenhouse effect works like this. The sun sends its heat down to Earth. If it weren't for greenhouse gases, this solar radiation would bounce back into space, leaving the planet cold and uninhabitable. Greenhouse gas traps the escaping heat in the Earth's troposphere, a few miles above the surface. And it's here, according to the climate models, that the rate of warming should be highest if it's greenhouse gas that's causing it.
All the models, every one of them, calculates that the warming should be faster as you go up from the surface into the atmosphere. And in fact, the maximum warming over the equator should take place at an altitude of about 10 kilometers.
A scientist largely responsible for measuring the temperature in the Earth's atmosphere is Professor John Christie. In 1991, Professor Christie was awarded NASA's Medal for Exceptional Scientific Achievement, and in 1996 received a special award from the American Meteorological Society for fundamentally advancing our ability to monitor climate. He was also a lead author on the UN's Intergovernmental Panel on Climate Change, or IPCC. There are two ways used by scientists like Professor Christie to take the temperature in the Earth's atmosphere: satellites and weather balloons.
What we found consistently is that in a great part of the planet, that the bulk of the atmosphere is not warming as much as we see at the surface in this region. And that's a real head-scratcher for us, because the theory is pretty straightforward. And the theory says that if the surface warms, the upper atmosphere should warm rapidly. The rise in temperature of that part of the atmosphere is not very dramatic at all, and really does not match the theory that climate models are expressing at this point.
One of the problems that is plaguing the models is that they predict that as you go up through the atmosphere, except in the polar regions, that the rate of warming increases. And it's quite clear from two data sets, not just satellite data, which everybody talks about, but from weather balloon data, that you don't see that effect. In fact, it looks like the surface temperatures are warming slightly more than the upper air temperatures. Oh, that's a big difference.
That data gives you a handle on the fact that what you're seeing is warming that probably is not due to greenhouse gases.
That is, the observations do not show an increase with altitude. In fact, most observations show a slight decrease in the rate of warming with altitude. So in a sense, you can say that the hypothesis of man-made global warming is falsified by the evidence.
The recent warming of the Earth happened in the wrong place and at the wrong time. If CO2 were driving climate change, then the temperature should have gone up during the post-war economic boom. And the rate of warming should be higher in the troposphere than at the surface. But the very opposite happened. So is there any evidence from Earth's long climate history that carbon dioxide has ever driven temperature change? One way of looking back in time is to drill down deep into the ice. And here, scientists have indeed found a connection between CO2 and the Earth's changing temperature. The ice cores are frequently cited in support of the theory of man-made global warming. But there is something in the ice core data that is very rarely mentioned. Professor Ian Clark is a leading Arctic paleoclimatologist who looks back into the Earth's temperature record hundreds of thousands of years.
When we look at climate on long scales, we're looking for geological material that actually records climate. If we're to take an ice sample, for example, we use isotopes to reconstruct temperature, but the atmosphere that's imprisoned in that ice, we liberate, and then we look at the CO2 content.
Professor Clark and others have indeed discovered a link between carbon dioxide and temperature. But the link is the wrong way round.
So here we're looking at the ice core record from Vostok, and in the red we see temperature going up from early time to later time at a very key interval when we came out of a glaciation. And we see the temperature going up, and then we see the CO2 coming up. CO2 lags behind that increase. It's got an 800-year lag. So temperature is leading CO2 by 800 years.
There have now been several major ice core surveys. Every one of them shows the same thing. The temperature rises or falls, and then after a few hundred years, carbon dioxide follows.
So obviously, carbon dioxide is not the cause of that warming. In fact, we can say that the warming produced the increase in carbon dioxide.
CO2 clearly cannot be causing temperature changes. It's a product of temperature. It's following temperature changes.
The ice core record goes to the very heart of the problem we have here. They said, if the CO2 increases in the atmosphere as a greenhouse gas, then the temperature will go up. But the ice core record shows exactly the opposite. So the fundamental assumption, the most fundamental assumption of the whole theory of climate change due to humans is shown to be wrong.
But how can it be that higher temperatures lead to more CO2 in the atmosphere? The answer lies deep in the oceans. The oceans contain vast amounts of carbon dioxide, and each year they emit large quantities into the atmosphere, far more than humans do. But oceans also absorb large amounts of CO2 back out of the atmosphere. And how much they emit and how much they absorb depends on the temperature.
As every school child knows from their geography textbook, the oceans and the atmosphere exchange carbon dioxide. When the oceans warm up, they release carbon dioxide into the atmosphere. When they cool down again, they take in the carbon dioxide and they store it.
But why is there a time lag of hundreds of years between a change in temperature and a change in the amount of carbon dioxide going into or out of the sea? The reason is that the oceans are so big and so deep, it takes literally centuries for them to heat up and cool down.
The oceans are vast, and they occupy most of the surface of the Earth. And it's because of this vastness that they take such a long time to warm up or to cool down, often hundreds of years.
The common belief that carbon dioxide is driving climate change is at odds with much of the available scientific data. Data from weather balloons and satellites, data from the ice cores, and from the historical temperature records. But if CO2 isn't driving climate, what is?
Isn't it bizarre to think that it's humans, when we're filling up our car, turning on our lights, that we're the ones controlling climate? Just look in the sky. Look at that massive thing, the sun. Even humans at our present 6.5 billion are minute relative to that.
In the late 1980s, solar physicist Piers Corbyn decided to try a radically new way of forecasting the weather. Despite the huge resources of the official Met Office, Corbyn's new technique consistently produced more accurate results. He was hailed in the press as a super weatherman. The secret of his success was the sun.
The origin of our solar weather technique of long-range forecasting came originally from study of sunspots and a desire to predict those. And then I realised it was actually much more interesting to use the sun to predict the weather.
Sunspots, we now know, are intense magnetic fields which appear at times of higher solar activity. But for many hundreds of years, long before this was properly understood, astronomers around the world used to count the number of sunspots in the belief that more spots heralded warmer weather. In 1893, the British astronomer Edward Maunder observed that during the Little Ice Age, there were barely any spots visible on the sun, a period of solar inactivity which became known as the Maunder minimum. But how reliable are sunspots as an indicator of the weather?
Take care. Bye.
I decided to test it by gambling on the weather through William Hill against what the Met Office said was a normal expectation. And I won money month after month after month after month. Last winter the Met Office said it could be or would be an exceptionally cold winter. We said, no, that is nonsense, it's going to be very close to normal, and we specifically said when it would be cold, i.e. after Christmas and February. We were right, they were wrong.
In 1991, senior scientists at the Danish Meteorological Institute decided to compile a record of sunspots in the 20th century and compare it with the temperature record. What they found was an incredibly close correlation between what the sun was doing and changes in temperature on Earth. Solar activity, they found, rose sharply to around 1940, fell back until the 1970s, and then started to rise again.
When we saw this correlation between the temperature and solar activity or sunspot cycle lengths, then people said to us, okay, it can be just a coincidence. So how can we prove that it's not just a coincidence? Well, one obvious thing is to have a longer time series or different time series. Then we went back in time.
So Professor Friis Christiansen and his colleagues gathered together astronomical records for the past 400 years in order to compare sunspot activity against temperature variation. Once again, they found that variations in solar activity were intimately linked to temperature change on Earth. It was the sun, it seemed, not carbon dioxide or anything else, that was driving changes in the climate. The sun affects the Earth directly when it sends down heat. But scientists have now established that the sun also affects us indirectly by regulating the formation of clouds. In fact, the sun affects the Earth in so many ways that perhaps it shouldn't surprise us that variations in solar activity correspond so closely with the Earth's changing climate.
If you had X-ray eyes, what appears as a nice, friendly yellow ball would appear like a raging tiger. The sun is an incredibly violent beast, and it's throwing out great puffs of gas, an endless solar wind that's forever rushing past the Earth. We're, in a certain sense, inside the atmosphere of the sun. The intensity of its magnetic field more than doubled during the 20th century.
In 2005, astrophysicists from Harvard University published the following graph in the official journal of the American Geophysical Union. The blue line represents temperature change in the Arctic over the past 100 years. And here is the rise in carbon dioxide over the same period. The two are not obviously connected. But now look again at the temperature record and at this red line, which depicts variations in solar activity over the past century as recorded independently by scientists from NASA and America's National Oceanic and Atmospheric Administration.
Solar activity over the last 100 years, over the last several hundred years, correlates very nicely on a decadal basis with sea ice and Arctic temperatures.
For many scientists, the conclusion is inescapable.
The sun is driving climate change. CO2 is irrelevant.
But why, if this is so, are we bombarded day after day with news items about man-made global warming? Why do so many people in the media and elsewhere regard it as an undisputed fact? To understand the power of global warming theory, we must tell the story of how it came about. Doom-laden predictions about the climate are not new. In 1974, the BBC warned us that severe storms and droughts might be signs of an impending catastrophe. And what was to be the cause of this climate disaster? The man behind the series was former New Scientist editor Nigel Calder.
In the weather machine, we reported the mainstream opinion of the time, which was global cooling and the threat of a new ice age.
Nature's ice dwarfs us and outstrips.
After decades of falling temperatures, experts warned that a cooler world would have catastrophic consequences.
There's the ever-present threat of a big freeze. Will a new ice age claim our lands and bury our northern cities?
But amid the doom and gloom, there was one voice of hope. A Swedish scientist called Bert Bolin tentatively suggested that man-made carbon dioxide might help to warm the world, although he wasn't sure.
And there is a lot of oil, and there are vast amounts of